Today, I will talk about how technical debt can kill one business and how Formula One teams instead manage to crack technical debt. My name is Luca Minudel, and I work in professional software development since 20 years now. Most of that time using Lean and Agile way of working. I started as a software developer and I gradually moved into the role of technical coach. And I start to coach also line managers, senior managers, and executives from the business side of the company. I would like to start telling you about my journey into technical excellence, because I think this story is a little related to the topic that we are discussing today. And I would like you to think about your own journey, how you expanded over time your understanding of what quality and technical excellence means in software development. For me, at the beginning, it was all about me and my computer, making sure that I was able to make the computer do what I wanted to do. That was my first job in professional software development. It was a part-time job to pay for my university. And I love to work with all that professional instrumentation and knowing that someone was paying me to do something that I loved. The other challenge for me at that time was on Friday afternoon, just a few hours before the cutoff for the release. At that time, I was making the last changes, the last tweaks to the feature before the feature was released. And all my focus was on not breaking down the feature in the last minute and not knowing how to fix that. After that, I started to realize that I was working together with other developers, and the meaning of technical excellence and technical quality involved also how we all work together in the same code base and how we collaborated with each other. After that, I started to realize that it was more than releasing a new feature, but it was also about support, maintenance, and evolution. My understanding expanded even further when I started to realize that there were many systems involved. The system used during the software development, the system into production, the front-end system, the back-end system, the database, the computers, as well as the network. And I would start thinking about how can you design the right system in order to create the right solution. At that point, I started to realize the importance of users and customers, to understand customers' need, their goals, and try to see how the feature could solve their problems. And after the release, having conversation with them and try to understand how the feature was actually helping in solving that problem or not. The next step for me has been to realize that my feature were also contributing to achieve some desired business impact. In this case, the business is winning races and winning the Formula One championship. So while I was writing lines of code, I could connect the line of code to the business goal that I was trying to achieve. This whole session is about the technical excellence. And technical debt. And I'm using a loose definition of technical debt here. Let me tell you more about that. I also talking about skills and quality debt. When someone make a bad decision, a bad technical decision because inexperience or because just it is a mistake that everyone do now and then. A poor decision that leads to low quality code, low quality design and feature, and defects such as bugs. The strict definition of technical debt instead is a little different. It is about deliberate taking shortcut in order to expedite the release of a feature for the business. It is when someone is perfectly aware of the consequences that the team will incur in loss in productivity until someone do the required refactoring to remove those shortcuts. So now we are in a phase where someone is taking a deliberate decision because it makes sense to do so from a business point of view. This is where the business strategy and the engineering strategy come together. And this is a key concept, a key topic for this presentation. I mentioned before that I work a lot with Agile software development, and the role of Agile software development for me has been very important to understand technical excellence and to move my technical excellence to the next level. At that time, Agile software development was all about the quality of the code, of the design, and of the technical practices. It was a minority movement in the beginning that was completely changing and subverting the status quo of the definition of good in software development. Nowadays, Lean and Agile are mainstream, and the focus is often on team practices, on management and leadership practices, but the technical practices are often forgotten. And this is why today we are still having businesses that struggle to deal with technical debt. In Formula One, things are different. Well, let's talk about Formula One for a moment. It is a multi-million-dollar business, and it's an entertainment with one of the largest audiences worldwide. It is also at the pinnacle of the motorsport. Think about that. Hospital crew from the operating room come to visit the pit stop crew to see how they manage to work closely together in such a short period of time and such confined space. US military came to visit and study Formula One teams to understand how they manage to create components, electrical components and mechanical components that operate under extreme temperature and gravity conditions. Formula One teams managed to do that in just a few months, while the military take years to do the same. Also, schools such as the University of the City of London, the Case Business School, came to visit Formula One teams to learn management lessons from them. Formula One teams, as you can imagine, operate under an incredible pressure. A pressure to constantly deliver and learn at the same time, because things quickly change and evolve in Formula One. And there are frequent, unescapable reality checks. Most of the time on Sunday at 1 o'clock, the race starts. Just a couple of hours later, the race will be finished, and you will see what are the outcome and the result of all the work that you did the previous week. Failure and success are out in the open. And under this incredible pressure that Formula One teams face when they are competing at world level, they manage to constantly learn, improve, and deliver. While most of the business struggle to do that, even if they are under a much less pressure. They struggle to understand that learning and improving and delivering, they are not two mutually exclusive activities competing for the time, but instead are two activities that help and support each other. Let's look at the story of software development in Formula One. It starts from the 70s when some teams start to introduce some sensor inside the car and in the engine to collect data during test events and during the race. This data is then downloaded in the garage after the run or after the race, and it is analyzed to improve the reliability and the performance of the car. 10 years later, in the 90s, some teams start to introduce electronic engine control units. It's a digital brain of the car that is used to maximize the performance delivered by the engine and to improve drivability, and also to maximize the efficiency of the fuel. But it is in the 90s where there is an explosion of use of IT and software development in Formula One. Now there are hundreds of sensors in the car that via radio are transmitted in real time. We have a real-time telemetry that is used at the pit wall and also in all test events to test the car, to set up and improve the configuration and setup of the car, but also to take important decisions during the race. And a lot of software applications are built on top of this continuous stream of real-time telemetry coming into the pit wall. Even more nowadays, the Formula One car uses computers. Think about the steering wheel. It is a long time that the steering wheel are a computer on car. And even more, Formula One car nowadays use drive-by-wire. What that means? It means that when the Formula One driver steer the steering wheel, when they push the gas or press the brakes, actually they are sending an electric signal that is going into a computer, then through actuators control the car. It is like if the driver is playing a video game, it is not mechanically connected to the car anymore. So think about this. We are talking about automotive, we are talking about cars, we are talking about combustion engine. These are one of the oldest industrial products. And nowadays, in Formula One, those industrial products have a digital heart and a digital brain inside. This revolution has happened in Formula One from a long time, but it's happening also in every business. Every business nowadays make a huge use of software. Every business nowadays is a software business. And slowly, software is becoming more and more important for every business. The big tech companies don't use to say IT, tech, or business anymore because IT is an integral part of the business. And even more, nowadays, in this digital economy, you can say that business and technology are one and the same. And this is a transformation that is going on from some times. The business were initially just enabling technology were initially just enabling or supporting the business. But nowadays, as you can see, technology is at the heart of every business and they are one and the same. When the technology side of things in Formula One continuously improve, it enters a positive spiral of continuous improvement, an upward spiral that goes from continuous improvement to technical excellence. For a Formula One team, it means going from having a good driver, a good car, and a good team, going from that to winning races. But this positive spiral can also go on the opposite direction. And this is what sometimes happens to some business. Some business that don't pay attention to the quality of the software goes from some technical debt into technical bankruptcy. And they go from a product that is not competitive anymore to market shares that are shrinking and profits that are also shrinking. So now I would like to share with you 4 stories. 4 stories where a business and a Formula One team take different decisions. Some of those are horror stories and some of those are success stories. Let me start with the first one. The first one that I call ramping up. This is a situation where a startup or a department of a business has just released their first successful product. So their expectation is to start to sell the product now that it is successful, to sell it to even more users. And to do that, they are entering international markets, going into new countries and bringing the new product there. And they're starting to have this conversation with the software development. So business and product sides of the company is talking with the software development sides of the company and telling what they need to do in order to do that. Something similar happens also in Formula One. In Formula One, we often use experimental feature and application that are created and tested just for a few users or just for a specific track or a specific race. And sometimes we realize that that experimental application or feature is working so well that we want to extend the use for every race and to all the users in the team and make that application become a standard part of the way of working of all race engineers. The companies that I'm talking about in this story are one fintech startup and one bank that wanted to achieve a geographical expansion with their products. What does it mean? That is what the business is telling to the software development department. They needed to change the product in order to support different regulation because different countries have different financial regulation. The fintech also need to support different payment systems because in different countries there are different online payment system in use and the customers have slightly different habits. So you need to tweak the application for every new country. But the application initially was created from a proof of concept. Then it turned into a prototype and then into a minimum viable product. Nobody knew if those applications were going to be successful or not. So in the development of those applications, there has been taken some shortcut and some corner has been cut. And now business and technology are having this conversation. On one side, the business would like to have those features immediately to immediately sell the application on in the new countries. On the other side, the software development department would like to stop to pay back all the technical debt or almost rewrite the whole application. And they are fighting to each other with these two opposites view. Well, in these two cases, business win the argument and technology have to pull a rabbit out of the hat. What does it mean? It means that in this case, the fintech company have duplicated the code base for every country so that they could implement those new regulations and those new payment systems without causing problem to the previous countries. The bank take a slightly different but similar decision. They started to introduce conditional statement and if everywhere in the code base. After a while, when change requests started to come in, or when new requests for new features started to come in, they soon realized that the development and maintenance time has been multiplied by the number of code base that has been duplicated. They started to hire a new team to deal with each duplication of the code base or each branch of those if statements spread everywhere. IT operations start to become more expensive too, and the headcount in the software department grow because of all those teams that have to be hired. It's less common, but sometimes also the technology side win this argument. And so the business is put on hold to wait until all the refactoring is done. And then the deadline is missed, the deadline is missed again, the refactoring is not finished, the reliability of the code base is not ready to be released. And this is what happened to the business, waiting for the solution to be ready. The business falls and the company is in a terrible economical situation. What happened in Formula One? Well, in Formula One and in Ferrari, where I worked there with Michael Schumacher, Massa, Kimi Raikkonen, and I left just before Alonso, we did things differently. We had, for example, some experimental features such as changes to pit stop strategy in order to support some special case, a pit lane position that was different in relation to the start line compared to the other track and races. But after making that experimental change, the race engineer discovered that the race simulation model was better simulating the overtake during a pit stop. So they want to use that feature everywhere to make this feature standard. We also have race engineers. You will be surprised, but race engineers know how to code. We give them access to the real-time telemetry, to the car setup information, and to the historical data via API. And they can access this stream of information through Excel or through MATLAB and Simulink. And they can implement their own computation and their own simulation. And when they see that they are extremely effective and valuable, they ask us to make this feature available to everyone. It means make the feature multi-user, multi-site, need to work on the racetrack, on the test track, and on the test bench in their own factory, sometimes in parallel at the same time. Need also to support remote access, so the performance team can connect remotely to the racetrack and provide insight to the race team at the track. You also need the data replication, security, backup, restore, support for the versioning, and then the automatic one-click remediation plan, the ability to automatically roll back to the previous stable version of a feature as soon as someone discovered a showstopper bug. The way that we did this in Formula One, it was not fighting between business and tech, but it was through a collaboration between and a conversation between business and technology. The business, our race engineer, themselves, they very quickly understood that simplicity is important. Race engineers, after every race, come home with hundreds of ideas of new features to be implemented. But we all know that there is time only to implement 10 of those features in time for the next race. And so they got used to prioritize the feature and the request that give us the highest competitive advantage to the team. But also in the code, we realized the importance of a strong focus on simplicity. Simplicity in gradually reducing the technical debt, not with the big bang. Simplicity in simple design, good enough emergent architecture, avoiding unnecessary complexity, avoiding every time of over-engineering, but also understanding from the business where new feature in the near future can change, which decision we took where there is more uncertainty, and so things are more likely to change. And exactly in those places, we started to introduce more flexibility in the design, more loosely coupled design, more separation of concern, and more possibility to change things. Now, I want to tell you about the second story. The second story that I call strategizing. This is when a company have already released a few products. The business made a lot of investment in terms of money. And at this point, the expectation is that they would like to be able to reuse part of the existing products in order to speed up the development of new products. They would also like to be able to switch some of the existing technologies to the latest technology, to rejuvenate the existing product, or simply to change it, to switch it to a different technology provider. This happened also in Formula One. in Formula One, the technology is constantly changing. And so Formula One team have to switch to new technologies. And they also want to reuse existing components in the software, of course, telemetry, setup of the car, historic data, and so on, in order to speed up the creation of the new system. So in this situation, in the story, in the two business story that I'm sharing with you, we have a fast growing online market research company and a fintech company that are having this conversation with their technology department. They are asking, tell me which components, which modules can I reuse to speed up the development of new products? Which part can I implement, integrating them with the external component? So they want to know what they can reuse, which component they can adapt so they can reuse into the new product, which components they can build from scratch so that they can start to use those components also in the old products and speed up their maintenance and evolution, or which services, standard services or standard components available in the market can be integrated to speed up the development. But because the business didn't take care enough of the technical debt before, what's going on is that there is a high level of high coupling and dependency in the code base. So the reuse of component, it's impossible, but also integrating standard services and standard component is an endeavor that is full of uncertainty, unpredictable. And you cannot make an estimate if it is worth the effort or not in terms of time or economically. So the software department go back to the business and say, this is the list of all the options available. This list is a menu with just one item, a code soup, like it or lump it. So now the business has an extremely limited option, and it find itself in a technology in a vendor lock-in because it cannot integrate or change the technology the way that they would like to. The approach that we adopted in Formula One was different. As I mentioned before, we also have to switch to new technology, new frameworks, new development environment. The International Automobile Federation, the FIA, changed the timing system. And to make a specific example, a few years ago, all the teams have to adopt a standard electronic engine central unit developed by McLaren Electronic Systems. Some teams, some of the big teams at the time, like McLaren, Renault, and Ferrari, develop their own custom electronic central unit, engine control unit, and telemetry. And they wrote a lot of software on top of that. Years and years of development and a lot of competitive advantage coming from that technological stack. So they started to discuss the race engineer with the software development. What should we do? Should we adopt the new standard software, the new standard telemetry software for the telemetry and the EC and the standard ECU? Or should we integrate that with our technological stack? And they start to discuss and they start to find a way to gradually reuse and integrate the new telemetry and the new ECU with existing technological stack in order to preserve the historical data and the huge competitive advantage of that technological stack. The software development team start to do this, gradually decoupling all the part of the code, working with the ECU and working with the telemetry. A telemetry that was completely different, a different concept, a different architecture, a different way of working. They start to decouple the existing telemetry, they start to separate the concern, they start to insert standard interfaces up to the point that it was possible to extract the old telemetry and connect the new one. It wasn't just as easy as that. The telemetry is so important for a Formula One team that you need to be certain about the reliability, and also the race engineer needs to feel confident about the telemetry. So we developed the ability to swap at runtime one telemetry architecture with the other. The race engineer during test and race event were able to test the old architecture with the new one, compare them, ensure the reliability, and at the same time build the confidence. So the next year, when the regulation changed and it became mandatory to adopt the McLaren ECU and the new telemetry stack, they could integrate the new telemetry in the old technology stack without losing years and years of work and competitive advantage. You see how different approach between traditional business and Formula One. Here I have a third scenario. Here we have a company that has been leading in that sector for a long time, but competitors are starting to catch up. They started later, they copied their solution. They have a code base that is younger, a technology that is new, and so it's fast for them to release a new feature. And the leading company is losing its advantage. Formula One faces similar challenges. There is a relatively small team working on a code base that is huge and has been developed for 20 years. And that small team is maintaining and evolving this huge code base. And every week, that team is trying to deliver the maximum competitive advantage for the team, and is competing against the software development team of another Formula One team. So the business side is asking to the technology find ways to go faster with shorter time to market and to reduce costs. And that's exactly what's happening in an online gaming and betting company. They were the first one to release an online poker game and online betting. But now things are not going fast enough. For them, adding new feature is becoming slower and slower and more difficult. It is like climbing on a human tower or playing Jenga. After every move, things become more and more difficult. The company is losing the competitive advantage, the products are aging, they are falling behind, the customers are unhappy because they see that the competitors have more advanced features. And also the margins are reduced because making those changes take more and more time. As I mentioned, even in Formula One, we face a similar competition with competitors. We want to improve our simulations, simulation of the performance of the car, simulation of the race. We want to improve our telemetry, our ability to compare different laps, to find insight in how to improve things, our ability to change the engine mapping to improve the performance. So we are constantly fighting to maximize the number of features, but even more than that, the value, the competitive advantage value that we deliver with each feature. And the way that the Formula One teams do that is to pursue technical excellence and make it fast and easy to change things, to maintain and to evolve the code base. We adopt the right practices to go faster and safer at the same time. The way that we find out which practices work is thanks to those very fast feedback loop. Every week at the end of the race, we understand the business impact of the technical decision that we took. how our engineering strategy was working well for the business strategy. And so we start to introduce test automation, for example. Years ago, before test automation was popular, I remember Ross Brown and Luca Baldisseri wondering, why are you writing twice of the code every time that you create a feature in order to write the test? Why are you taking more time? But then after we started to write automated tests, we start to identify bugs and problems in the existing simulation software. And they started to realize that it was well worth spending that time. And after that, when we received the request to make substantial changes to the simulation software, it was possible to do those changes quickly and safely because of the availability of all those automated tests. Instead, before, it was an extremely risky and lengthy operation to make those changes. We also adopted some of the practices related to continuous delivery. And again, at the time, continuous delivery books and papers have not been published yet. We adopted something that nowadays is called trunk-based development, feature toggle, but most of all, the ability to roll back every feature to the previous stable version, so that as soon as there is a bug, we can, in 1 second, even during the race weekend, roll back to the version of the software that is working, even when the new version is breaking backward compatibility with the base, with the database, or with the client-server protocol. We use emerging architecture and design. We minimize the duplication. We avoided over-engineering, no speculative generalization, no unnecessary complexity, no dependencies. And through this technical excellence, we went from a situation where adding more feature was becoming increasingly harder to a situation where adding more feature and releasing software felt an extremely relaxing activity. We had lower accidental complexity, and we were taming irreversibility, creating the ability to quickly reverse decision and recover from mistake quickly and safely. Now, this is the final destination, the last example that I want to share with you before going to the lessons learned. This is where the situation is reaching the dead end, really. The business is struggling to ensure the basic product reliability. And again, in Formula One, reliability is fundamental. But let's see what these businesses are doing. The business is the same business that I described before, the online gaming and betting company. And they are really struggling because most of the time they're working on firefighting, fixing bugs, and trying to avoid service interruptions. Everyone is busy fixing bugs. So product managers and business people come up with the idea of creating 2 groups of teams. One group of teams dealing with the bugs and the maintenance problem, the other groups of teams working on new feature. And I'm sure you can guess what's happening next. Those 2 teams start fighting with each other because the teams that develop new feature, they try to deploy new feature quickly. It doesn't matter if there are a lot of bugs. Someone else will take care of that. Instead, the group of teams that are working on fixing bugs, they just put a quick patch on top of every bug. They don't care to remove the root cause, to change the practices and the way of working that lead to that mistake. They don't take care of that. They just fix a quick bug. The result, as I mentioned, is that those 2 teams are fighting each other, and the productivity, instead of going up, goes down 10 times. This company lost momentum. This company has been bought by its competitor company. They migrated the users to their platform, and then they throw away the old code base and the old IT department. As I mentioned before, reliability is incredibly important in Formula One. race engineer, they need to focus 200% on the work that they are doing and in trying to win the race and try to make the car go as fast as possible. They do not have time to deal with bugs. They do not have time to deal with workaround on the software. So reliability is important. In the recent year, you may have heard how sometimes bugs have negative consequences or can cause a team to lose a race. I remember last time it was Hamilton, that because a bug in the strategy software, the team made a wrong decision and they lost the race. So in Formula One, instead of using separate release and maintenance team, like the previous example, we had the software team taking care of the full cycle from the beginning to release, support, maintenance, and evolution. Instead of just fixing bug, we were constantly reflecting and removing the root cause, changing our process, changing our way of working in order to avoid a repeat of the same mistake. Instead of waiting at the last mile to do quality assurance, we were constantly testing, adopting pair programming, code reviews, unit testing and automated testing, even before they were popular, automatic remediation plan, as I mentioned before, the ability to quickly roll back safely every time that there is a serious bug. So we created this incredible ability of going faster and safer at the same time. It seems a paradox, but this is what we achieved with an incredible attention to technical excellence. And this brought extremely valuable benefit to the business. This is where the engineering strategy meet the business strategy. So I would like now to wrap it up before moving to the questions and the conversation with you. I would like to quickly recap all the learnings that comes from my experience in Ferrari and working with the Formula One teams. The first learning is a growing mindset, the understanding that improving and learning sustain the delivery, and the delivery sustain improving and learning. Those two activities support each other and need necessarily to go together. The idea that some companies see those two activities as mutually exclusive is not right. The second learning is about the blameless culture. In Formula One, we are constantly at the age of new technology, and we are pushing the boundaries of what is human possible to do. So making mistakes happen, but we want a blameless culture so everyone can openly share what they did in order to contribute to the genesis of that mistake. And only with a blameless culture you can collect that information. And with that information, you can prevent that problem to repeat itself, because then you change your process, you change your way of working, you change your practices. In Formula One, a software engineer is only blamed when she or he create a problem because ignoring one of the way of working, one of the practices that was put in place exactly to avoid a repeat of that problem. This is only when you can get in trouble. The other element is business and technology collaboration and trust. And let me tell you how we achieve that. I already told you before one example where Ross Brown and Luca Baldisseri mentioned and asked me, why do you want to write twice the code in order to automate the test? But then that trust that I asked to them to work the way that I was used to delivered tangible results to them. So first thing to win trust is to deliver on the promises of technical excellence. The second was sharing with the race engineer the responsibility of our work. We as a software developer, some of us started to go in the office during the race weekend, connect remotely with the track and support the IT operation and the race engineer. Monday, we usually had a post-race report with all the issues reported during the race weekend. And there, instead of try to blame each other, we started to act as one team, taking the success as well as taking the failure together, and the dynamic completely changed. Also, our business started to be open to understand the technology implication and constraint as well as the opportunity, and they become open to work with us in order to find solution together. So the next lesson learned is about the technical mastery, that it is a necessary starting point. Technical excellence is built on top of technical mastery. And let me take the opportunity to share some of the lessons that nowadays have been forgotten on how to achieve, how to develop practices that help technical mastery. Let's focus on the goal of the technical practices. Those are the three key principles that the technical practices need to follow in order to contribute to technical excellence. They need to increase the speed of learning, they need to reduce the cost of change that inevitably will come, and they need to make it easy and cheap to reverse previous decision and to recover from mistakes. And those are a few tips in order to develop technical practices that do exactly that. Focus on specific problems. Don't try to focus on generic or universal solution. Start with local solution. Don't be taken away by the scaling obsession. Start simple and evolve things. Start making simple things work and then evolve them. Adopt a just-in-time and just good enough approach. Don't try to find perfection up front. Focus on one thing at the time, no multitasking. And then if something is hard, do it more often. Don't wait while the problem is growing bigger. The last lesson learned that is very important for me is that technical excellence need to be pursued in context, the context of your business. What I mean with that, let me make an example. This is your technical mastery, the one that you need as a starting point. And this is your business needs and your business goal. But one business may have specific needs and specific goals that are different from another business. Technical excellence is the ability to connect your technical mastery to the specific business goal of that business. When you go and work on a different product, on a different business, the meaning of technical mastery changes. And then you will have to pursue different business goals and different business need. This is again where engineering strategy meet the business strategy and they come together to achieve business and technological excellence. So this is a quick screenshot of the 5 key learning from Formula One teams. The presentation session, the frontal presentation now is completed, but what I would like to do is start to have conversation with you. So I would like you to write, go on your Zoom, click on the question and answer icon and do 2 things. Start to write your questions or also comments and topic that you want to discuss and start to vote the question and topic that interest you. And then we will have a conversation with you. I will ask Mattis, that is here with us, to open your mic and your camera, and we will start to discuss with each other. So please, let's take just a few seconds to give you time to write your question and to get the conversation going. So I think that we have one question now with the number of votes. We have Moore, Lamar. So Matthews, can you open the mic of Moore and also the cam and let him tell us about his question? Hi, Moore.
Hi. Yeah, my name's actually written backwards, so it's Lamar. Yeah, so I was just wondering. I guess it's self-explanatory. So you've got a certain amount of resource. How do you split that between addressing your technical debt issues and developing new features in a production environment?
So to be clear, Lamar, this is what the online betting organization did. They initially all the team was taking care of fixing bug, and then a smaller part of the team was taking care of the new feature. But I tell you, that did not work well at all. I observed this in other organizations, and I can tell you that model is really not effective. I observed two similar organizations, one with 40 developers and one with 400 developers doing exactly the same job. But one organization have all of them taking care of all the life cycle, so bug fixing as well as new feature. The other instead has this module of two separate teams, and that did not work. Talking about the size of the team, in Formula One, a team of software development goes from 30, 50, and more people.
So you mentioned about having this collaboration between the technical people and the business, so that they build enough trust to believe that what you're doing is, I guess, the right thing in addressing your technical debt. How do you go about convincing people that are putting loads of demand on you for new features that addressing your technical debt will actually make things easier down the line? How do you quantify that and convince them?
Yeah, so to be honest, there is something in Formula One that make it easy. As I mentioned before, in Formula One, every week we had a race. And after the race, you see the business impact of your technical decision. So you have immediate feedback. When you take shortcut, those things become visible to the business. But then there is another element that was important. The first is that we delivered on our promises. All our software engineers, they were incredibly responsible. When they asked to tackle some technical debt, they invested time and then they showed tangible result to the business. And this is how they build the trust. The other element that I mentioned before is that we started to act as a team. We start to have the business in what they were trying to do. In our case, they were race engineer. We start to share the success with them, and we start also to share the failure and take the responsibility together. In that way, they start to feel that we were part of the same business, and the trust and the collaboration start to build. So those, in my view, has been the key factors. You need intelligent and mature software engineer, and you need intelligent business people also. Does this answer your question, Lamar?
Yeah, it does. I mean, it seems to me like the first step is going to be the hardest step, but I get what you're saying.
Thank you. Anyone else want to comment on this? If you want to comment on this, raise your hand and Mattis can open your mic. I don't see anyone now, so I think I would pass to the next question. Richard, Mattis, can you bring Richard open his mic and bring him on cam? How early did you build modularity in?
Hello.
Hi, Richard. Do you want to tell more about your question? If you want to open your cam, you are free to do that. Otherwise, there's no obligation.
I thought it was already on, but I'll go on with the question. I was wondering, I mean, you talked about the modularity that you built into your system so that you could quickly and safely iterate and try different strategies and compare old ones against new ones. But when were you able to build that modularity in? Was it when you had the first sort of alternative that you wanted to build? You said, hang on, we'll build that for you, but let us refactor the engine first so that we can then swap different ones in and out? Or did you build your architecture to allow that sort of plug and play from the start, which would have massively slowed down your initial sort of system development and required you to have had a lot of foresight? I was just wondering at what point you started doing that.
I think exactly as you say, not only foresight, but since we don't have a foresight, when we try to create extra flexibility where it is not needed, we may risk to waste the time that will not create the benefit that the business is looking into. So we took two different approaches. On something, we can predict a little the future. For example, if you are working on a tire degradation, the model for tire degradation, the strategy lead, Luca Baldisseri, can tell us, I want to start to work in this area. I'm making some experiment. This is the feature that I want to build now, but things will change very quickly. So you know that you need to build some flexibility in that code. The design in that code need to be open to easy refactoring and flexibility. For that specific example of the ECU, the engine control unit, we didn't know it was coming. It's like if you develop your application and one day someone come to you and say, I want to switch to a different database vendor, and half of your software was in the store procedure. But what was different is that we know that few months ago, because of course switching an electronic central unit is a massive change, we started gradually to do that. So we had the time to do that. And we could count on the professionality of software developer and on the availability of the race engineer to test things with us. So we didn't waste the time with the political things, and we gradually make that change. But we haven't done that before. Only after it became clear that was necessary, we took that route.
Thanks. It seems that a lot of your solutions are to keep things focused on a specific area. So not trying to make everything customizable. Just make the one area you now want to work on customizable. That way you're not having to guess too much ahead of time.
Yeah, and also not having a lot of ballast with you. With ballast, I mean technical debt. I mean a code base in a terrible situation. I mean a feature block of unnecessary features. So all that simplicity that was a result of an act of mastery, all that simplicity make it possible to make that change together with the quality of the software engineer, the learning that we had on the code base, thanks to those fast feedback, and the collaboration with the business.
Thank you.
Thank you, Richard. Since no one raised their hand, I think that we can move to the next question. I see Emily. Hello, Emily. Nice seeing you here. Mattis, can you bring Emily on cam and open mic?
Hello, hello.
Hey, do you want to tell me about your question?
Well, I mean, I'm just curious really about, you clearly have achieved a culture of technical excellence, and I'm wondering how you went about training the developers. Did they come to you already with skills to write this code in this way, or did you do something to train them?
So I can tell you what happened specifically there. It wasn't the same for all the developers, but first we had some training, generic training about design. We had some generic training. Some of us were already into extreme programming, so tried to do refactoring stuff, but we reached a plateau. We had a situation with the unit tests that were not really unit, were integration and a lot of dependencies. Then someone from the Conextra team, Paolo Polce, joined our team and start to introduce some TDD technique. And two things happened. Our skill and our own understanding of the design, together with the feedback loops that come with the TDD approach, and the feedback loop that we had thanks of those frequent release and immediate visibility of the business impact, bringing all these things together, we learned how to do things.
That's a real success story. So this guy from Conextra joining you came with he had better skills and knew TDD better. Were you like pair programming with him, or how did he spread those skills?
So he started to talk about something that sounded crazy to us. For example, introducing a lot of interfaces in order to enable TDD, breaking down dependencies, injecting the dependency only into the constructor, and starting to break down a large method and the large classes. Some of us, everyone was focused about delivering stuff. No one was asking to learn, but some of us had an intuition that behind those crazy ideas, there was something crazy because we were using a different design style. But we had this intuition and we started to try things. Someone started to have a conversation with Paolo. How you doing? Let me see. Someone more junior was pairing with him. Someone like myself, I was observing him and then pairing with other people in my team. And then that was the starting point. But you know what makes things crystal clear is that we work in that way. We made the changes on the code base on a feature in that way. We released that feature. The next week, we had to work again on that feature, and it was clear that we were working better and faster. So we were also learning by doing it, working in pair, copying from him.
Excellent, excellent. So I'm hearing that the feedback that you got from having to deliver every week, and yeah, that was a big part of the learning as well. Thank you.
Emily, I know that you work in this same area. Do you want to share some other suggestions?
Hey, I had a whole keynote earlier. I'm good. Thank you.
Okay. Thank you very much, Emily. We have another question from Scott that is the most voted. Feel free to ask more questions and keep voting the question that interests you more. Scott, welcome.
Hi, can you hear me?
Yes, it's. Can you speak a little louder?
Yes, I'll try. Is that better?
Yes.
Great. So yeah, I just was curious because you mentioned about week by week deliverables. If you've got like a chunk of work and that particular system is in a pretty bad state, and say it's going to take weeks or months, how do you tackle that kind of task? How do you break that down?
Yeah, I can tell you the strategy that we used. I don't remember exactly the number, but the size of the code base was in a million line of code, while the team was relatively small. It was a code base that was 20 years old, not all the code base, but it started 20 years ago. So can you imagine how much stuff was in it? So this is what happened in Formula One. usually there are changes in regulations or there are opportunities, and those opportunities start to happen in some area. And so what we did was to start refactoring on the area where we were building those features and making those changes. In that way, we were immediately benefit from the refactoring. We were doing a refactoring and getting the benefit immediately after because we were working in that area. So I think Ken Beck call it, I'm not sure if I'm quoting incorrectly, but the technique that it is tidy up. You first tidy up in the area where you are building the next feature. In this way, you gradually tidy up the code base in the area where you are changing the code base. And after a while, you will end up touching and improving and removing the technical depth of the code base in the area that change more often. And this is where you want to have a code base in the best condition.
Okay, yeah, great. Thank you.
Thank you, Scott. I think we have some time left. Richard is next. If you have more questions or if you just want to make a comment or discuss a topic, put it on Q&A. Click on Q&A, write your comment, your question that you want to discuss, and vote the question. Richard, you're next with your next question. Go ahead.
Thanks. I was wondering, I mean, obviously you've been using computers at Formula One for decades, and how did people used to do it? Was it ever a traditional waterfall approach where you would design software that would then take a year to build before you'd start using it? Or was the weekly cycle, do you think the weekly cycle in F1 actually forced you into an iterative methodology much earlier than a lot of other industries?
I can tell you that at the very beginning of Agile software development, more than one team start naturally to explore Agile software development mainly because of the speed of Formula One and because of the rate of change. Yes, the weekly races tend to push you toward an iterative approach, but at that time, remember that we had races and test event and on-factory test event going on in parallel. So it was not exactly an iterative approach, even if the most important heartbeat was the race one. What brought Ferrari into Agile software development were two things. First, Toyota and Lean. You know that Agile is connected to Lean.
Yep.
So even from the engineering point of view, we had to do, the Formula One team had to achieve things that are incredible from a manufacturing point of view. So we had the Lean culture. We had responsible, Pier Giorgio Grossi, responsible of the software development that was also not only into Lean, but also into complexity. So going into Agile was natural. I know that some team was more conservative, more into a waterfall, so they decoupled software development from the actual Formula One team. They use a waterfall style and then deploy the software in Formula One only when it was ready. No need to tell you they were incredibly slower. Some other team, even some person in our team adopted what is called, someone call it a cowboy style. So there was no process. These people were also making acts Saturday morning before the race. I can tell you that that software was a mess to maintain and had a lot of bugs, and make my life easier because when I arrived and I showed the professionalism of our way of working that was fast, adaptable, but professional, it was easy to win the trust of the people.
Just to clarify, you said, so when you arrived or started to try to introduce agile processes, you already had examples within Ferrari where people were both doing it much slower or more conservatively with waterfall, but you also had the other extreme of people who were pretty much just hacking on the fly, and you were able to come in with a middle ground that was much more professional, as you say.
Yeah, let me correct it. The team working in a waterfall style was a different team, and not in Ferrari. In Ferrari, maybe electronic was more conservative because they were working on something a little more. The electronic department was going a little slower, and in our team we had. Not exactly waterfall, but we had a more conservative approach and some approach that were extreme. And I came in with something in between. When I say I do automated testing and they could fire me like that, I was really naive. But after three races, it was evident. And 1 year later, when there was a substantial change to the race simulation part of it, we could do it easily. It was no problem with all those tests and with our refactoring, cutting code, breaking down dependencies, simplifying the building process and everything. Yeah.
Oh, fantastic. Thank you.
Thank you, Richard. Michael, you're next.
Hey, can you hear me?
Yes. Do you want to share your question with us?
Yeah. So I was wondering how you managed to find a balance between keeping your features simple, but still kind of keeping development speed up, because I imagine that a lot of the time abstracting things will make things easier to work with in the long run. So how do you find that balance?
Yeah, look, we learned that balance. We learned that balance thanks to the frequent feedback. But I will say is that tidy up concept. You start to improve things and to make things simple in the place where you are working now, because it's likely that if you start working on one side of the code base, it's likely that even the next week you may go back and work in the same area of the code base because the feature worked well and they will ask you to do more of that, or because the feature wasn't perfect and they will ask you to improve things, or because there is something that is changing and evolving coming from the regulation or some other external factor. So the tidy up approach, tidying up where we were working, that's what worked for us.
Mm-hmm. All right. Thank you.
Thank you, Michael. And I think we have the last question for now from Dan.
Hi, can you hear me?
Yes, hi, Dan.
Yep, hi. So the question is, I think you mentioned at some point about automatic rollback in case of software failure, and I was wondering, like, if there's more than one thing that updates, like I guess there can be different software components that could potentially put the whole system in a state that it's not performing well.
Yes.
How do you know to what previous state to roll back?
That's a very good question. So first, we started to roll back only application that don't create problems. So I'm talking about application that do not change the database schema, do not change the structure of any file, do not change the use of external components, do not change client and server protocols. Any change, so we started to make the rollback work well with all those versions that were backward compatible. Is it clear so far?
Yep.
So that was the starting point. But we knew that in order to be able to do the rollback, the application needed to be backward compatible. We start to understand how important and valuable was to maintain backward compatibility. It really simplified the life. As a developer, we were always thinking about breaking compatibility in order to do something better. From real life, we realized no, maintaining backward compatibility is an incredibly source of simplification. But then, when we realized what was creating backward compatibility, what was breaking backward compatibility, we start to keep track of those things. So every time that we were changing something that was going to break backward compatibility, and this is what is causing the problem that you, Dan, mentioned, we knew that. But that was the first part. Then we developed a technique that I call two-phase release, that enabled us to roll back even in the presence of a backward compatibility. I had a session about this 2 years ago here, and you can find the link of that session and also example on GitHub, a few examples on how to break down a release in 3 steps, just like the two-phase commit of a relational database, so that you can roll back even in the presence of compatibility breaking changes.
Okay.
Does this make sense, Dan, or
Okay, thanks.
Thank you, Dan. We have another question from Scott, and we are approaching the end of the session. Go, Scott.
Hi, can you hear me?
Yes, go.
Cool. Yeah, I was just curious because presumably I don't know how you deal with bugs and things. So if you've got week by week deliverables, presumably you've got kind of a list of bugs and you triage which are the most important. I wondered if there was like a certain area of your, your 20-year code base that, you're not planning on making any major changes to it, but you keep getting recurring bugs. Like at what point do you decide, okay, it's worth going and refactoring this system, even though we don't plan to change it much functionality wise to solve that tech debt, so to speak?
Yeah, I think, Scott, I think you are giving me the opportunity to clarify one thing. We adopted a technique that is called continuous refactoring. This idea that we are constantly and continuously refactoring the code base. So we never stop. We haven't done like the example of those businesses that they wanted to stop to do refactoring, but instead we continuously do small refactoring. Our race engineer, they prioritized the bug as well as the feature, and based on which one is giving the biggest competitive advantage. If next week I can have one thing, which one will bring more value, fixing this bug or implementing this feature? And so they prioritized things in this way, and we were constantly doing refactoring anyway. So it's not that we had to stop and do refactoring. Does this make sense, Scott? Or
it does. I get the idea of you're constantly looking at the priorities and you're constantly refactoring. I guess what I'm trying to say is that, as you say, you prioritize which areas to refactor, right, based on which gives you the most bang for buck. But there's always going to be those areas that maybe they're contributing to like niggly bugs, like not major things, but there's a lot of them and they happen a lot. But because there are always other priorities which give you more value for the time, when do you decide you want to go back and fix those less of a priority issues, but they're still there in the background? If that makes sense.
Well, there are. Why? I'm trying to understand. I'm only trying to understand the question. Why would you like to fix a less important bug that is not giving the most important value to the business? Why would you do that?
I don't know. I guess sometimes you've probably got a number of users, and it might just be that one of these 30 users finds this issue really annoying, and because it's only affecting them, maybe, and it's never going to get fixed. It's not a priority, but it affects that one person in a great way, maybe.
Yeah,
this kind of thing.
Now I understand. Thank you, Scott. In this case, we facilitated. So we had software that had multiple users. We facilitated the conversation between them. So we had the chassis department. We had the engine department. Gearbox department. And so on, and some of those were working on using the same product, the same application. We facilitated conversation between them so that each one of them got the fair share of time and the possibility to push their request on top. And also we had the team dedicated to the customers so that that team could prioritize things for that specific customer. So even if it wasn't super important for another department, they could still raise the priority for them.
Okay, yeah, that makes more sense. Thank you for that.
Thank you, Scott. I think we answered all the questions, and the time, well, we have 6 minutes left. If you have any comments that you wanted to do, otherwise the session is finished. I don't see any more question and comment come up. Let's see on the chat. No? Thank you everyone. Thank you for the questions and thank you for attending. Bye everyone.